Okay, so in this continuation, we're going to be working on exercise 6.1. In the first video, I modeled this connector within the assembly environment. So we've got that part. All the other parts were given to you in Blackboard, and now we're ready to start assembling. I'm going to start by constraining these two spheres into place. They go inside the body, and something that I think can be somewhat helpful to model or to see what you're doing is to select that body, highlight it, and come up here to the material. And right now it's made of smooth ivory. It has smooth ivory finish. We can change that to clear. And clear will allow us to see the internal features a little bit better so we can see what we are constraining to. So the first sphere we want to constrain into the top of the body, and it's going to rest right here on this chamfer right there. So here's how we do that. First, constrain the sphere to the axis. Okay, and you can see that it doesn't move from side to side. It's constrained on that axis, but it's still free to move up and down. So we want the sphere to sit right down onto that chamfered surface. And so I think it's actually easiest. Even though we've made it clear, it's hard to select those internal features from the outside. It's best to orbit the shape so you're actually looking down into the hole. And let's apply a second constraint. I'm going to select the tangent constraint to make this sphere tangent to that chamfered surface right there. Now I put it on the bottom. That's not where I want it to be. I want it to flip the other way. So I'll select this inside rather than outside tangent and apply that. Now if I cancel that and then I try to move the sphere, it doesn't move. It's constrained into place exactly where I want it. Okay, let's do the same thing now with, or a similar thing, with the other sphere. Let's constrain this sphere to that central axis. And then, let me move this out of the way so I can then see down in there. And that's the surface I want to make it tangent to. So I'll tangent the sphere and that edge. And again, put it on the other side. I'm going to flip it, apply it, close it. That sphere is constrained in place. All right, so if I go back to the home view or the front view, I can see those two spheres are sitting inside the body exactly where I want them. And if you want to now, you can go ahead and put the finish back onto smooth ivory, or you could just leave it clear. I guess I don't really care about the finish here, but I'll put it back smooth ivory. Okay. All right. This part, this is the union. This gets inserted into the top of the body. So if I orbit around to the back side, this is the side that sits down inside the body. I will constrain it with an insert constraint. I'll choose the central axis and I'll select this ring right here, which is what's actually going to sit on top of the body. And when I choose the body, I want to make sure I'm selecting both the central axis and that top surface. Now, in reality, this would probably either be a tight press fit or I don't think it's threaded. It didn't look like it was threaded, but in reality, we probably wouldn't want this to spin freely around. But as long as it's inserted, that's fine with me. I suppose if we really wanted to prevent this from spinning around freely, I could give it an angle constraint. So I could maybe make this surface and the back flat surface of the body have a 0-degree angle with respect to each other, and apply that, and now it doesn't rotate. But as long as it's inserted, that's really all that matters. Okay, this bottom piece, the seat, goes into the bottom. So again, an insert constraint will allow me to place this into the bottom. And again, it's going to rotate around. If I don't want that to be the case, I can always give it an angle constraint. So let's see here. Actually, I think what I can do, it does look like in the image that this groove we want running in this direction. So I don't want to make one of the flat sides of the hex parallel to this. Instead, I'll make it perpendicular. So I'll give a angle constraint, the first type of angle constraint, between that surface and that surface. I don't want it to be 0 degrees. Instead, I'll make it 90 degrees and apply that. And see, now it doesn't rotate. Okay, so what else? The RAM. The RAM goes inside the connector. Again, I'll use an insert constraint here. I'll get the underside of this ridge, and that's going to insert into the main hole of the connector and be flush with the top surface. Okay, and so now those two things are connected together. The what is this? The seal. The seal goes on the underside of the connector. So I'm going to again, I know it seems like we're using a lot of insert constraints, but it's really a really useful tool. That's how a lot of assembly is done. Things are inserted. Let's try applying that. Did that go the right way? Yes, yes it did. So I've got the seal sitting just underneath the connector. That's good. And now I'm going to want to insert the seal from the bottom of the seal. I want that to sit down inside the body until, let's try to orbit around here. That's going to go sit right down onto that ridge right there. Let's apply that. Okay, so I actually want to flip that to be an aligned insert. Nope, I guess it's going to force me to do that again. So let's try that again. I've got the inside of the body and the bottom of the seal. That popped into place. That's what I want, and apply that. So yeah, when you're applying a lot of these constraints, they have two different directions. You've got your mate and a flush. You've got different types of angles. I almost always use the first angle. We've got inside and outside tangent. We've got opposed and aligned inserts. Sometimes if the way you do it first is wrong, just flip it. Just kind of do a trial and error. The last thing I need to do is pop these bolts into here. So I'm going to actually use the bottom of the fillet. There's a fillet on the underside of the head, which I'm not sure if that would interfere with the hole. So just to be sure, I'll choose rather than the underside of the head, the bottom of that fillet, and select the hole there. Apply, and see that went the wrong way. So let's try it the other. No, I've already applied it. So what I'm going to have to do here, if you apply a constraint that you didn't mean to, just go back here, find it in your model browser, and delete it. And let's try that one again. Constrain, insert. I'm going to go ahead and proactively flip it to the other option here and apply that. There we go. Okay, and again, the bolt spins in place. In reality, if that's tightened down, it wouldn't. But I'm not really worried about that, whether the bolt spins in place or not. As long as it's inserted, I would consider that to be fully constrained. Same with the RAM here. The RAM rotates. I think that's fine. So just one last insert constraint here to go. Let's insert that bolt into that hole and apply it. And that looks good. Okay, so this is now fully constrained. The only thing I would like to change right now is the work plane that I used when I made the connector. I don't like seeing work planes in a finished submission. So I'm going to expand the connector in my model browser, and we need that work plane. I can't just get rid of it, but I can hide it. I can turn off the visibility, and that to me looks much better. It looks like a much more clean, finished product. So there we have this assembly. I'm not even sure what it is. It's some sort of valve, I guess, or some pneumatic piece of equipment, it looks like. But I've got the caps, the spheres, the RAM, the connector, everything is fully assembled into place. So that is exercise 6.1. Once you have this complete, if you would, please make sure that you include all of the files that were included in your assembly, zip them all together in one zip folder, and upload to Blackboard.